So the first article that I want to explain about RST parsing is this article. But before that, I want to introduce two great books from the same author, Manfred Stede, and I think he likes PDTB more than RST. So I want to explain this article from China that I introduced in the end of last lecture. So this is an example of RST discourse tree. We have a bunch of elementary discourse units, and then attribution and elaborations are relation labels. So it uses a transition-based system. If you have watched my lecture on shift reduce in a playlist of I think second lecture of my playlist on dependency parsing, then I explain stack queue with an example. So the idea of that they use in dependency parsing could also be used for discourse parsing as well, no problem. So you have changed the scope, you have changed the granularity. Now it is very, very fine. Now it is very coarse instead of the previous fine approach in dependency parsing. But in discourse parsing is a little bit coarser. And of course in topic segmentation it's very coarse. It goes even beyond sentences, it goes beyond texts. And so let's come back to this idea of transition-based system. So we have some actions, just like reinforcement learning. You have some states, and you have some action. Your actions says the relation between the nodes. For example, these nodes. For example, this is elaboration, or this could be. So it's a tree, and you want to capture the relations. First of all, you should do segmentation, because if you don't segment, you don't know what are the elementary discourse units. So use shift reduce, and you pop as usual. So in shift, which removes from the first EDU in the queue onto the stack. So you have a buffer, you have a stack as usual. This is the top of the stack. Of course, we use the first three of this and the first one of this for our machine learning in order to say what is the relationship. So three of this and one is from buffer. If we give it to neural networks and it says what is the outcome, I mean the relation, the action that you should say. For example, that is elaboration. So this is as simple as this. I wish somebody could tell me in email why this approach is not good. What are the problems of this approach for discourse parsing? So this is the encoder-decoder approach, as I said. We propose a transition-based neural model for RST discourse parsing, which follows an encoder-decoder framework. Given an input sequence of EDUs, elementary discourse units, E1 through EN, the encoder computes the input representation. So you give E1, E2, EN, it gives you hidden states, HN, H1, so, and then, of course, we use bi-LSTM for the first layer, but for the second layer, we use a bi-LSTM of X. And X is just an average pooling of your hidden states in the previous layer. And of course, it has augmented with the positive speech part of speech tag, TI. So each word has a part of speech. So you concatenate it, and then you give it, so this is the X, the input that you put. So unfortunately, this approach uses it needs part of speech, because the part of speech learning, which is a kind of classification, has its own errors. So you are feeding the error from a previous task to the new task. So it's not good. So this is one of the problems. But please email me and tell me why this approach is not good. The encoder, so this is the output, always the output score. So depending on S0, S1, and S2, that from, as I said, top 3 stack subtrees, and the first EDU in the queue. So we use them to calculate the output score for each of these relations. And W is just a simple model parameter. But note that the hidden vector, HE, is obtained directly from the encoder output. So this one is from encoder output. And the hidden vectors are represented partially parsed subtrees. So these are partially parsed subtrees. And so we do the training as usual. We use softmax to get probabilities. And of course, we use L2 regularization in machine learning. And so what is PDTB? So this is another topic, PDTB discourse parsing. It is sometimes called shallow discourse parsing because it's very easy, just this local connectives. You find some connectivities, some connective words, such as a result of, blah, 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 in order to do this parsing. So the set of 4 subtasks for PDTB discourse parsing was laid out by Lin in the first complete system with separate tasks for explicit task 1 through 3 and explicit task for connectives. So these are for find the discourse connectives, for example, as a result of. And you should do word sense disambiguation, of course. That is a major challenge because each word can have lots of meaning in different contexts. The second one is find the 2 spans for each connectives. For example, blah, 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 as a result of, blah, blah, blah. So find the 2 spans, span 1, span 2. And then label the relation between these spans. What is the relationship between these spans? Assign a relation between every adjacent pairs, but it only looks at adjacent pairs. I don't like it because it doesn't, because a human, when you read a book, a story, you need to know the connections between different very long sentences, very long text. So it's not just adjacent pairs of sentences in order to capture and get ready for reading comprehension. So each of the other tasks has been addressed. Task 1 is to disambiguating discourse connectives from their non-discourse use. So determining whether a word is a discourse connective is thus a special case of, as I said, word sense disambiguation. So similarly, once is a discourse connective indicating in temporal. So here is a temporal relation. It's a discourse indicating temporal relation. But here, once doesn't have that meaning. It's not discourse. And let's talk about lexically grounded model of coherence. So given a list of discourse connectives, because, also, as a result of, when, since, result, and an unlabeled document, annotated labels. So we want those connectives and also the spans of text that they connected. And of course, these connectives may be implicit, as I said. So there are four main classes for PDTB. So it's either temporal, it's either comparison or contingency or expansion. And of course, each one has its own subclasses. It is good for local stuff, as I said. Only at the span pair level, no hierarchical tree structure. We are not looking for something complicated like this. For example, comparing, here is comparing this one as this one. For example, elementary discourse unit and E3, E4. We are not comparing this one with this one. So it's not like this. And it's only good for local stuff. Oh, sorry for breaking the silence, but this logos is a Greek word. I have lots of Greek friends, so I know they told me that it means speech. And speech, so of course it means discourse. I mean, an argumentative kind of speech, not all speeches, but it's a speech. So it means that philosophers tend, when they talk about speech, they want to understand something. They don't waste their time by talking nonsense. So they want to argue and see and capture the meaning of that. That's why discourse is the meaning, is sharing meanings when two people talk or when something is written in a text. So the meaning is important. And why discourse is about meaning? Because you're using logic. Maybe that's why Western people use logic for translation of logos. But logos is much deeper than that. Because it's talking about discourse, a coherent set of sentences that are very coherent, related. It has a centering word and those things.